Okay, I'm going to start doing a few Newton's first law examples, a little more complicated than the simple ones I've done so far. First one I've done is sort of a typical easy problem. Essentially, the picture is we have a 2-pound weight. It's hanging from a string. The string is knotted here to two other strings, one of which horizontally goes over and is attached to the wall, the other of which goes up at 37 degrees relative to the vertical and attaches to the ceiling. What do we want to know? We want to know everything we don't know, which is the tension in this string, the tension in this string, and the tension in this string. So, what do we do first? Choose a body. I am going to choose the knot. All right, so here's the knot. I'm going to choose that as my body. And I'm going to ask myself, what are all the forces on that body? Well, there is a tension in this string. Let's call that T1. There is a tension in this string, which I'll call T2. And there's a tension in this string, which I'll call T3. Okay. And that's all the forces there are on the knot. 3 strings, each pulling on the knot, but the knot's in equilibrium. Okay, the next thing we do is choose a coordinate system. Now I didn't have to choose this coordinate system, but you see here that this coordinate system is the cleverest to choose because T3 is easily resolved in this coordinate system and T1 is too. The only one we have to do work on when we're resolving our forces is T2. So let us proceed and write down what all the components of the 3 forces are. Okay, so T1 sub x is equal to minus T1. T1 sub y is equal to 0. T3 sub x is equal to 0. T3 sub y is equal to minus T3. Okay, and let me, I've told you here what the trig functions are for 37. I'll use 37 a lot because it's got nice easy sine and cosine to remember. So T2 sub x is equal to, and let's in fact, let's use the green pen to show the components of T2 here. So here is the T2 sub x and the T2 sub y. So you see that both of these are pointing in the positive coordinate direction. And so let's go back and what was I doing? Blue. So T2 sub x is equal to T2 times the cosine of 37, which would be equal to T2 times 0.8. And T2 sub y is equal to T2 sine 37. Getting a little messy here, aren't I? Okay, which is 0.6 T2. Okay, so now we're ready to apply Newton's first law. Sum of the forces in the x direction is equal to 0, which is equal to minus T1 plus T2 sub x, which is 0.8 T2. Okay. Sum of the forces in the y direction is equal to 0, which is equal to minus T3 plus T2 sub y, which is 0.6 T2. I'm going to draw a box around those guys. Now I ask myself, do I have as many equations as I have unknowns? And I have 3 unknowns and 2 equations. And so I have to choose another body. Okay. There's only one more thing I can think of to look at, and that's the 2-pound weight here. And so we have a weight down, which is the vector 2, I'll call it. And the force up, of course, is the tension in that string, T3. And so I'll choose plus y to be up, and I'll say the sum of the forces in the y direction is equal to T3 minus 2, and that has to be 0. So T3 is equal to 2. So T2 is equal to, where do we go here? It's T3, which is 2, divided by 0.6, which is 3.33 pounds. And T1 is equal to 0.8 times T2, which is 2.67 pounds. And that's the end of the problem. Everything is now known. Now let me say a word or two before we leave this problem. You might have wanted to say, hey, look, I didn't really need to do this step because I can say that the 2-pound weight is a force on the knot. But that's wrong. The 2-pound weight is a force on the 2-pound object. It is not a force on the knot. And you could have said, well, but I know that the tension in this string is equal to 2 pounds. And I would have said, I'm glad you know that because we've done this kind of problem over and over again already. But here's a very important word of warning. As soon as we start doing Newton's second law problems, if you look at a problem like this, if you look at an object which has weight, which is hanging from a string, and you say the tension in the string is equal to the weight of the object, you're very likely to be wrong. Because if the 2-pound object is not in equilibrium, that is, if it's not at rest or moving with constant velocity, suppose that it's accelerating upward, then the tension in the string is going to be different from the weight. Okay, that's the end of this problem.